Now let's do a more difficult problem right now. So here we have to find a combination of what we have just seen. We have to find the equation of tangent and we have to find the equation of normal. So we have to find two equations and then we have to find the point of intersection of these two lines. So we have to find the point of intersection. So that is the idea. There is no point of intersection without the equations. The first task is to find the equation of the two lines. Equation of the tangent first. Okay, so let's start. The equation of the curve. The tangent is drawn to a curve. And the equation of a tangent is the equation of any line. It doesn't really matter. So this is the curve. So this is a quadratic equation. So we can have a parabola over here. So the point is the tangent is drawn at 2, 5. So the point where the tangent is drawn is 2, 5. And we have a tangent at this particular point. So our task is to find the equation of this tangent. So the equation of the curve is y equals to x squared plus 1. Derivative of y is dy by dx. Derivative of x squared is twice x. Derivative of 1 is 0. We don't have to write that. Now we have to find the gradient at the point 2, 5. So x equals to 2. That's all we need for the time being. So dy by dx is going to be 2 into 2, which is 4. Gradient of the tangent is going to be the same as the gradient of the curve. So the gradient of the tangent is 4. Now we have to find the equation of the tangent line. Remember, the equation of the tangent line is the same as the equation of any line. So this is going to be y minus y1, which is 5. Gradient is 4. X minus x1 is 2. So we have y minus 5 equals to 4 into x is 4x minus 4 to the 8. So we have y minus 5. So we can send the 5 to the other side. So y equals to 4x. 5 minus 8 is minus 3. We found the equation of the tangent line. Now the next step is the equation of the other line, normal line. So this is equation 1 because we have to solve simultaneous equation for finding the point of intersection. So we have to find the equation of the normal, and the normal point where we have to draw that is at the point 1, 2. So let's assume we're not doing any plotting here, just a rough sketch. So this is 1, 2, and if we draw the normal line over here, 90 degree, so then we can find the equation, and later on we can find the point of intersection. So let's find the normal. So we already know the gradient. So at the point 1, 2, x equals to 1. We only need the value of x for the gradient here. So dy by dx equals to 2 into 1 is 2. So the gradient of the normal, remember, it is the negative reciprocal of the gradient of the curve. So it would be minus 1 by 2. Reciprocal means you divide 1 with that number. So minus 1 by dy by dx is the gradient of the normal. Now we have to find the equation of the normal. Equation of the normal is going to be same as any other line. We're calling it the normal line. So it's going to be y minus y1, which is 2. Y coordinate is 2 equals to m is minus half. X minus x1 is x minus 1. Let's cross multiply. 2 into y minus 2 equals to minus 1 into x minus 1. So we have 2 into y minus 2 to the 4 equals to minus x into minus 1 into x is minus x plus 1. Let's find the point of intersection of the two lines. This is where the two lines meet. So the point of intersection is solving the simultaneous equations. So by the question, equation 1 is y equals to 4x minus 3. So this is equation 1. Equation 2 is, let's simplify, 2y equals to minus x plus 5. This is equation 2. Now we can solve simultaneous equation by the elimination method. But here I prefer to use substitution method, where you put the value of y in the second equation. So y equals to 4x minus 3. You plug it in and you simplify. That's all. So I plug the value into the second equation. 4x minus 3. I plugged it in the second equation. So now let's simplify this. 2 4s are 8 x minus 2 3s is 6 equals to minus x plus 5. So 8x plus x equals to 5 plus 6. So that's going to be 11. So therefore 9x equals to 11. So therefore x equals to 11 by 9. That is one of the point of intersection. That is the x-coordinate of the point of intersection. Remember, every point has two values, a value of x and a value of y. You need to remember this, that we have to find the y-coordinate also, because we have to find a point. So the y-coordinate, we can put it in any of the equation. Let me put it in the first one because it is easier. So 4 into x. In x we plug in 11 by 9. So 4 into 11 by 9 minus 3, and we get 44 by 9 minus 3, and it turns out to be, so 44 by 9 minus 3, and it turns out to be 17 by 9. So 17 by 9. So that is the y-coordinate. Remember, we have to write it as a point. To write it as a point, it has to have open bracket x-coordinate comma y-coordinate close bracket. That is the notation. So x-coordinate is 11 by 9 comma y-coordinate is 17 by 9 bracket closed. So that's the point of intersection. Now let's do a similar sum here. So we have this expression fx. Now fx is the function. Many times the equation is given in terms of a function and we write y equals to function. So ultimately the equation is y equals to that. So y equals to 12 minus 4x plus twice x squared. So that is the equation, and it is given in function so that it's easier to write it down, fx. So we have to find the equation of the tangent. So this is a quadratic. So this is a parabola, and we have a point. Now this time the point is not completely given. Part of the point is given, x equals to minus 1. So we have to find the y-coordinate because we don't know what is the complete point. So this time it is incomplete. The information is x equals to minus 1. So we can simply find it out by plugging in the equation of the curve. So 12 minus 4 minus 1 plus 2 minus 1 squared. That turns out to be 12 plus 4 plus 2, and that is going to be 18. So we have the point minus 1, 18, and that is the point where the tangent line is touching the curve. So let's find the derivative. So derivative of y is dy by dx, which is also the gradient of the curve, and we know this, the rule. Now the next one that we have is we have to differentiate this. So d by dx of 12 is 0, then minus 4x is minus 4, and then we have 2x squared is 2 is the constant. We keep the constant there. X squared is twice x. So minus 4 plus 4x. That is the gradient. Now at the point x equals to minus 1, dy by dx is going to be minus 4 plus 4 into minus 1, which is going to be minus 8. So that is the gradient of the curve at the point minus 1, 18. So gradient of the tangent, remember, it is exactly the same as the gradient of the curve. So it is going to be minus 8. So this is the tangent line. This is the point. And the gradient of the curve at that point is dy by dx. And the gradient of the tangent line is throughout minus 8. That is, remember, a line has a fixed gradient. A curve is like a valley or a mountain. Different point, different types of slope. So equation of the tangent, like any other line, y minus y1. So y minus 18 equals to gradient is minus 8, x minus x1. x1 is minus 1. So we can write y minus 18 equals to minus 8. It's a good idea to simplify, because otherwise later on bracket inside bracket. So I always prefer to simplify it first. So let's write x plus 1. So write x plus 1. So we have y minus 18 equals to minus 8x minus 8, and we can simplify this. So we can write y equals to minus 8x. So if the 18 goes to the other side, it becomes 18 minus 8 is 10. So that's fine. So that is the equation of the tangent, our first equation. Now the next is to find the equation of the normal at the point x equals to minus 1. So we know what we need for the equation of a normal. We know the point, which is minus 118, and we know the expression for the gradient. So let's find the gradient of the normal, which is the negative reciprocal minus 1 by dy by dx. You have to remember, so the normal is like a stab. Since the point is the same this time, remember this time the tangent and normal they're drawn at the same point, so it's like a stab. It is piercing the curve, and the tangent is like a slap, just touching the curve. So the normal is going to have a gradient of negative reciprocal. We already know the gradient of the curve at that point. We figured it out before, we calculated it. This time it is going to be minus 1 by minus 8. Minus 1 by minus 8, which is going to be 1 by 8. So equation of tangent line, normal line, equation of normal line is going to be the same as equation of any line, y minus, no, that's the gradient. So the equation is going to be y minus y1, y minus y1, which is 18, gradient is 1 by 8, x minus x1, so x minus minus 1, it will become positive. So cross multiply, it's always idea to leave out the fractions. So 8 into y minus 18, x plus 1. So 8y minus 8 into 18 is going to be 8 8 is 64. And 8 1 is 8, so it's going to be 144. So 8 into 18 is 144. So 144 equals to x plus 1. Ultimately it becomes 8y equals to x plus 145. That is the equation of the normal. The next question is, find the coordinates of the point where the tangent and the normal meet. Meet means point of intersection. Now notice they have already been drawn from the same point, and two lines intersect at exactly one point. They cannot intersect at more than one point. So this is what is here. They're intersecting at the point minus 118. So that means we don't have to do anything else. We don't have to solve the simultaneous equations again, because the point is going to be the same. So when you have a tangent and a normal at the same point, that is the point where they meet. So minus 1, 18, that is the point of intersection.